hundreds of startups have emerged in this aerospace industry. Most of them are speaking additive manufacturing technology because they want to reduce the cost of launch. But according to manufacturing market report, additive manufacturing technology has been adopted just for 1% and it will rise to 5 to 10% in the next decade.
Oh, very less number.
However, I was unable to grasp the heights when I said component is 3D printed, as many discussions are exaggerated about additive manufacturing technology.
The field's actual adoption is far less than the way it discussed. What do you think the reason is?
The low adoption rate is due to the difficulties in large-scale production and adapting the existing design to 3D printing. Well, I had an opportunity to discuss with the ISRO scientists who worked in Chandrayaan 3 mission. They stated that they have challenges in adapting the existing design to 3D printing. However, they have a 3D printer rocket in their chamber.
Oh, okay.
Yes, and experts from this additive manufacturing technology who worked in aviation and satellite components, they say
business way I call this as CTQ, cost, time and quality. If I'm able to meet cost, time and quality, irrespective of this technology, I will adapt this technology.
Okay.
And that is taking time for additive manufacturing to prove on cost, to prove on the quick turnaround times. Quality per se, okay, I understand the functional enhancement, it definitely makes sense. Cost and time, still a long way to go.
Yeah. Yes, Mr. Joseph. So I have a question. What do you think of our injector head, which is printed as a single piece?
I like it. I saw the video. I really like it. Believe me, I saw how the channel, the angle went in and all. I have my technical advisors as well. So I spoke to one and they told me that the angle is one of the major criteria for the injector to optimize the fuel, right? If you are able to achieve it, 90% of your job is done.
yes.
Right? They say all you have to do is you have to increase your pressure rating, and the very fine cut that you are able to do it, that makes a lot of sense. The higher the pressure limits, better it is. That's what they say in space industry. I'm not from space industry, but as I hear from some subject matter experts, they say higher the pressure ratings, better efficient it is. And I'm very glad to hear from Vignesh that it has reached much better than you have set a target limit and it has reached much below that. So, congratulations to your team.
Thus, AI technology is highly efficient. There are several challenges we confront. For example, achieving low surface roughness, improving the strength while reducing the support structure. Very well, this is a single piece component that does not require any post machining process. There is no support structure in it, and we have achieved the surface roughness up to 8 microns in the flow area, and outside it is 2 microns.
Oh, I'm wondering how you came up with zero support structure design for this difficult component.
Yes, it is complicated, but not impossible actually.
Innovative mindset.
Maybe I'm afraid. However, we have gone through a lot of struggles, a lot of iterations, a lot of simulations. Finally, we entered with this design.
Consistency is the key.
Hence proved. Do you know what, Nancy? This design is a template that can be easily expanded for different mass flow rate.
Oh, brilliant thing it does. So, how was the experience in flow testing?
What did happen to the last 10? I ran away with my life, fast forward, never turn back again. It's kind of funny that the more we pass time, the more we need to set them rewind.
Pressure valve check.
The year I had to leave you, but now I'm seeing all the signs.
In the count of
3, 2, 1, on!
Can't believe it's true. I'm just as surprised as you.
Your journey was incredible and inspirational. Building anything from nothing is challenging, and Spacim, on the other hand, created one that is unique. Wow.
Thanks very much, Miss Nancy.
Maha, one final question. What drives you towards success?
Honestly, I don't know, but success is painful.
Ironically.
I won't feel that pain.
Seriously?
I mean, deep.